We're going to finish this series on solving matrices using row operations by talking about Gauss-Jordan elimination. As you've just seen, a Gaussian elimination works down to give you a matrix that looks like this. So that there are ones in this diagonal and there are zeros here, and all these things with blanks might be different numbers. So that you end up with z being equal to that piece right there, and then you can use back substitution to solve the matrix. Now, with Gauss-Jordan elimination, we're going to work our way back up so that the matrix looks like this. We're going to continue to use row operations so that the matrix looks like this. And what that will mean is that z will be equal to whatever that number is there, y will be equal to whatever that number is there, and x will be equal to that number right there. So let me put my calculator back up here and I'll show you how we'll finish this off. Okay, we were working with that matrix right there. And let's see, I think we need to save that matrix. I'm not sure that it got saved. So let's store it back in matrix A. And now what we want to have happen is for there to be a 0 right here. So we're going to work with row 3 and row 2 to make a 0 happen right there. So we're going to multiply row 3 by -3 and add it to row 2. So let's go get our row operations. There. Multiply row, add, and the first thing we want to do is name our multiplier, which is going to be -3. Now we name our matrix, matrix A. Now we tell it which row gets to be multiplied to -3. That would be row 3. And then what row we're going to add all that to, which is row 2. Close our parenthesis, press enter. Magic! Now we can see that y is equal to a -1. Let's save this matrix. Store matrix A. Alright, then we can work with row 3 and row 1 to get a 0 right here. So that means we just have to multiply third row by a -1 and add it to row 1. So go back and get our row operations over to matrix, and that is a -1, 2 of matrix A. Oops. Okay. Alright, I see what I did. I pressed the wrong sequence. I chose go to, so I'm back here. I can finish this command now. And I wanted to do that to row 3. And I wanted to add the result to row 1. There's my matrix. So now I'm getting zeros right here. Need to save this matrix. Second matrix A. And then the last step, work with row 2 and row 1 to get a 0 in that position in row 1. Same sort of command. Second and matrix, math, up to multiply row, add. I want a -1 multiplied to a row in matrix A. It's row 2. I want to do this too and add it to row 1, replacing row 1 with our new result. Okay, that tells us that the solution for this system X is 2, Y is -1, Z is 1. And we're done. That is Gauss-Jordan elimination using row operations with your calculator.